next curve, and a very important curve for the rainfall, we call the intensity. Change the new color. We call intensity, duration, frequency curve, or IDF curve. This curve shows that this axis is duration and this axis is intensity, and it represents the frequency in terms of the return period from 2 years to 100 years. Okay, this is IDF curve. And the next, we can look at the next figure is the IDF curve for Nakhon Ratchasima province. Okay, in this axis is from minute to hour. Okay, and this vertical axis is rainfall intensity millimeter per hour, and this line show the return period from 2 years to 500 years. Okay, we can practice to use this IDF curve. Look at this example. Estimate design rainfall intensity for duration 2 hours. So TI is 2 hours, and return period 5 years for Nakhon Ratchasima province. So what is the desired rainfall intensity? So we can look at this curve and start from the duration. Duration is 2 hours, so we focus on this 2 hours, and find the line of the 3 return period at this point, and project to the axis is about 40. So for 2 hours duration of rainfall with the 5-year return period, we got 40, and rainfall intensity is 40 millimeter per hour. Okay, so this one we can, in this case, I is equal to 40 millimeter per hour, but total depth of rainfall is I times TR, so it's equal to 40 times 2 hours. Is depth of rainfall is 80 millimeter. Okay. The next, we should know how to construct of IDF curve. There's the first step. We have to calculate annual series of maximum rainfall for one duration is 5-minute duration. So that is the maximum rainfall for one duration. And it's next, the second, ranking the data from the maximum to minimum to put the ranking number. The third, calculate return period from this equation. This equation is just we learned from previous lecture about T is equal to the sample size plus 1 and divided by ranking. Okay, from the previous lecture. And the next, plot on the Campbell paper. Okay, and fifth, read the intensity for 5 until 100 year return period. Okay, and write the table. In this case, we just read from the curve. We can do another way by the fitting curve and do calculation. And for sixth, repeat for step 1 to 4 for another duration for 10, 15, 30 or 24 hours. And last, plot on the log paper and draw the fit curve for each return period. Okay, we start from the first set. Is this set. This is annual time series for maximum rainfall data. This column is for 5 minutes. This for 10 minutes, 15 minutes. Okay, and this number is from the observed data. How to get this? We have to record rainfall depth from tipping bucket for automatic recorder. We can, for the example, we can record for every minute. For the first minute, okay, second minute, and the next we just put the frame for the 5 minutes. Let's say like this. Okay, just different color. Okay, for 5 minutes, and we make summation is about 3, and we can move again to another 5 minutes. The summation is 3, and we move again until we finish for the whole day. Okay, a whole year, not whole day. Let's say this is 4. Okay, move again. Summation is 5. Okay, something like this, and we just pick up one maximum number. For example, we pick up 5 for the maximum millimeter and put in here maximum 5 meter for this year, and we do the same for another year. We got 6 millimeter, and third year got 7 millimeter. So that is the maximum rainfall for 5 minute duration. Okay, and the next step, we just start with the 5 minute. Okay, when we put the ranking. Okay, the maximum one is 15 is the ranking number 1, so we can just find the period. This period is equal to 27 number of sample plus 1 divided by ranking is 1, so we got this number 28. Okay, for this is ranking number 2, so it's equal to 27 plus 1 divided by 2, so we got 14. Okay, that is how to calculate the return period based on this equation. Okay, the next we plot the return period t with the depth of rainfall. That is the next graph. This we plot the depth return period t with the rainfall depth for 5 minutes. Okay, each red dot represent the 27 year from the observed data, and this plot is for the 10 minutes. Okay, we can do for the 10 minutes. Okay, we can do for every duration of the, let's say 10, 30, 1 hour to 3 hour. Okay, to plot the return period with the depth of rainfall with different duration.